So let me take I to be equal to the integral. Now we will utilize the Liet rule where u will be equal to 4x to the power of 3 and dv is equal to d squared over dx squared of 1 negative x squared raised to the power of 5. I differentiate this, I get du is equal to 12 times x raised to the power of 2 times dx. I integrate this. The double derivative will lose its derivative. One derivative will be chopped off, giving us d over dx of 1 negative x squared raised to the power of 5. We will use this formula uv negative integral v du. So my u is 4x to the power of 3. My v is d over dx of 1 negative x squared raised to the power of 5. The limits are 0 to 1. Now negative, my v is d over dx of 1 negative x squared raised to the power of 5. My du is 12 times x raised to the power of 2 times dx. The limits are 0 to 1. Now this is going to be 4 times x raised to the power of 3. Now we have to differentiate this 1 negative x squared raised to the power of 5. That is going to give me 5 times of 1 negative x squared raised to the power of 4 multiplied with the derivative of 1 is 0. Derivative of negative x squared is negative 2x. Okay, fair enough. So the limits are 0 to 1. I'm going to rewrite this. 12 is taken out. X raised to the power of 2 times d over dx of 1 negative x squared raised to the power of 5 times dx. Now we can actually simplify this first. Okay, so 4 times 5 is 20 times 1 negative x squared raised to the power of 4 times negative is also there, so it's going to be negative 40, and I will just place the x here and the limits are 0 to 1. Okay, so we can take negative 40 followed by negative 12 times integral 0 to 1 x squared d over dx of 1 negative x squared raised to the power of 5 times the dx. Now I substitute the upper limit, the entire term goes off. I substitute the lower limit, entire term goes off. So now my u is equal to x squared, my dv is d over dx of 1 negative x squared raised to the power of 5 times dx. Okay, so over here we need to have that dx also. Okay, when we are taking that quantity. So now I integrate both sides, I get v, this derivative will be lost, giving me 1 negative x squared raised to the power of 5. So I use the formula uv negative. Okay, over here du is equal to 2x times the dx. So applying all these components to the formula uv negative integral v du, you will have u is x squared, my v is 1 negative x squared raised to the power of 5. The limits are 0 to 1 followed by negative. The integral b is 1 negative x squared raised to the power of 5. My du is 2 times x dx. Now I substitute the upper limit 0, substitute the lower limit 0. So this is what I get. Now one more component we will have to cater to. Now this entire quantity is within the bound of, or within the realm of negative 12. So if that negative 12 is coming in, this will become positive 24. Okay, so we will have to integrate 24 times x of 1 negative x squared raised to the power of 5 times dx. The limits are 0 to 1. Now if I were to take 1 negative x squared to be equal to sum u, negative 2 times x dx is equal to du. So I can rewrite this as 12 times of 2 times x 1 negative x squared raised to the power of 5. The limits are 0 to 1 dx. So x and dx are there. Okay, just a negative sign has to be catered to, so I'll push that to the other end. So 2x dx is equal to negative du. So this will become negative 12 and you have a du there, and this is going to be u, right, raised to the power of 5. and the limits, if I were to substitute the lower limit, I get 1. I substitute the upper limit, I get 0. So this can be flipped. So it's going to be 12 times. I need to integrate this, right? This is nothing but 12 times integral 0 to 1. The negative sign will be lost. U raised to the power of 5 du. So this is u raised to the power of 6 divided by 6. The limits are 0 to 1. I substitute the upper limit, lower limit will be 0. So 12 over 6, which is nothing but 6 divides 12 2 times. So 2 will be the ultimate value for this question. Okay, I hope you are watching. So this is a lovely integral. Please like, share and subscribe. Thank you.